Hello, I am Joshua Maloney, and this is my presentation for Coastal Zone Management on the failure analysis of Texas Tower 4. I will describe the study, explore the scientific principles involved in its design and failure, list the ecological and economic impacts of the Texas Tower program, and discuss the results of the case study. The purpose of the 2002 case study was to see if modern ocean engineering technology and knowledge about storm forces could lead to a better understanding of current platforms in order to understand the causes of the failure of Texas Tower 4. The case study found that the failures were centered and initiated in the lack of prediction techniques to anticipate the extreme environmental loads, which led to insufficient design criteria. Their lack of advanced analysis tools and methodology to formulate the wave loads and structural response led to a design that had defects, especially including pin connections. The last major reason for collapse is the human and organizational malfunctions during installation, repair, operation, and the decision-making on evacuation, which contributed to the total loss of the platform and heavy casualties. The Texas Towers, named for their resemblance to oil drilling platforms in the Gulf of Mexico, were an innovative ocean engineering accomplishment. They served a legitimate purpose in America's defense. Soviet submarines and fleets of loitering Russian fishing trawlers would swarm the towers. One airman remembers thinking, "Some nights the lights were so thick you thought you were back at Coney Island." A body of legends grew up, telling of damp footprints in passageways and mysterious strangers sipping coffee in the mess hall at 3 a.m. Despite the tower's isolated location, they were known for having high morale based on increased budgets for food, recreation, and rotations that were beneficial to airmen's life. Funds were 70% above their parent squadron, and food allowances were 14% over stateside allowances. 6 weeks of tower time could earn an airman 2 weeks of off-duty time, a favorable morale factor. The towers had a hobby shop, pizza parties, barbecues, daily beer rations, and movies every night. They were artificial islands with 300-ton steel deckhouses that served as housing for personnel, radio equipment, and the foundation for the Arctic Tower. The Texas Tower radar information fed into the SAGE project. This project exceeded, both in funding and the number of military, civilian, and contractor personnel involved in the Manhattan Project. Due to point-to-point tropospheric scatter systems on the tower, anyone could call home after duty hours by dialing the Otis operator on a phone on the tower. Though the designers were provided the best oceanographic and marine geology information at the time, before the 1960s, little was known about wave formation. Probability studies established a criteria of 125 mile-per-hour winds and 35-foot breaking waves. In the 1950s, there were some theories that proposed that random pressure fluctuations in wind significantly generated wind waves. We now know that waves are controlled by wind velocity, wind duration, and fetch, or the distance over which wind blows. 3 engineering and construction companies bid on the tower construction. The DeLong Corp specialized in the design and construction of marine platforms and similar structures. They pioneered the design and erection of marine platforms for the use throughout the world. They constructed and engineered offshore drilling platforms in remote parts of the world, such as the Gulf of Mexico. They evaluated all of the problems with installing these structures at sea and formulated fair estimates for all 3 towers. Their estimation for TT4 was $1 million more than TT1 or TT3. They were different towers, so the DeLong Corp considered the logistical differences in installing the towers in 50, 80, and 185 feet of water. After J. Rich Steers Inc. outbid them by $1 million for TT4, DeLong testified that he assumed the lack of knowledge by the competing bidder led to similar estimates for TT3 and TT4. J. Rich Steers Inc. was a heavy construction outfit who built more marine work than land work. They had rehabilitated harbors, installed radio stations, and completed many marine construction jobs. They saw the tower as a marine problem, and that is why they bid on it. Having limited knowledge of jacking assemblies in the ocean, they partnered with a company that had one of DeLong's associates who had experience jacking up platforms. Here are the respective water depths. When the DeLong Corp saw the original plan for TT2, it had bracing between the legs. Mr. DeLong testified saying, "There is one thing we can all be sure of. The ocean is not going to get tired. You will get tired. A metal or anything else will tire before the ocean will get tired." The legs of TT2 went into the ground almost 50 feet, while TT4's legs, which held the platform 250 feet above the ocean floor, went into 18 feet of sand. Mr. DeLong later testified, "You are on awfully shaky assumptions that 18 or 20 feet is enough." Being isolated with miles of sea between it and the shore, each tower was conceived with limited space into the design. Inside the legs of TT2 and TT3, each steel leg had another steel tube, and the space between the two was filled with concrete. The inner steel tube was 6 feet in diameter and held thousands of gallons of fluid reserves. The hollowed legs held water, fuel, and seawater tapped for conversion to drinking water. While TT4 was being constructed on land, J. Rich Steers Inc. requested the Navy engineer to allow for pin tolerance increases. The design specified 1/64 inch tolerance, but they requested 1/16 inch for above water pins and 1/8 inch below water pins. Captain Foster, who oversaw the project from the Navy, approved all of these tolerance increases. TT4's legs were different than the other towers. Not only did they have below water bracing, but buoyancy struts in the legs allowed the leg and brace assembly to float across the ocean to its site. It floated on its A and B legs, while the C leg acted as the vessel's gunwale. During transportation, 2 braces broke off the legs and floated away. Mr. Rao of J. Rich Steel testified that he did not make any recommendation on whether to take it back to port or undertake the repair at sea. As the builder, he testified that he would have followed any course that the owner suggested. Captain Foster oversaw the project from the Navy and approved the upending of the tower. New braces were specially fabricated on shore, and they were the same height and size as the original braces. They were pinned at the same way as the original braces, but attached to the legs by 2 half sleeves which formed a collar. After the original brace broke off, only a steel stub remained on the leg, so the design had to be different. This work was completed in September of 1957. A report in December of 1958 revealed that approximately half of the bolts were loose and could be extracted by hand. Divers reported that the bolts were not of design, diameter, or length, and that some of the holes were oversized. Additionally, the A leg was leaking oil from an area covered by the collar. There was no way to remedy this leak, so it was recommended that the tower continue to operate without repairing the leak. Each tower had its own unique movement. TT2 was a juggling motion, TT3 was a twisting motion, and TT4 weaved, wobbled, and lurched like a living thing. Having helicopter support and logistical support coming from the 4604 Texas Support Squadron at Otis Air Force Base, from the time the Air Force took over responsibility of the tower, the airmen had already nicknamed TT4 Old Shaky. On September 12, 1960, Hurricane Donna hit Texas Tower 4 with winds of 132 miles per hour and breaking waves exceeding 50-foot height. This exceeded all design specifications, and the tower was seriously damaged in the storm. The post-storm estimates that the overall strength was 55% what it was before the hurricane. Texas Tower 4 wasn't the only tower with problems. With the installation of Texas Tower 2 and the beginning of its radar operation, the line-of-sight nature of radar created low-altitude gaps that the towers overlooked. These gaps had to be filled by radar mounted on aircraft known as the Super Constellation or Warning Stars. Despite the Air Force's efforts to make the islands at sea a habitable place to be stationed, even the most stable airmen spending weeks aboard the platform could get tower fever. The isolation, bone-chilling cold, screaming wind were unbearable constant noises that seemed built into the tower. In foggy weather, the world's largest blowhorn blasted every 29 seconds. The horn of Texas Tower 2 once blasted for 3 weeks straight while hidden in fog. The escape facilities were limited to increasingly dangerous methods. Knotted ropes could be suspended over the side, and crew members could climb them to get from the tower's platform to the ships floating in the sea below. Helicopter transport to and from the tower was the most preferred method, but Atlantic wind and weather ultimately dictated that service. The mission of flying to the towers was so dangerous that helicopters only flew in pairs, so if one of them went into the sea, the other could begin immediate rescue operations. Therefore, when one helicopter landed on the platform's deck, the other had to hover overhead, making loading and unloading a time crisis. The only other method on or off the platform could not be rivaled by anything in nautical or aeronautical history. The device primarily used to transport personnel between the tower to supply ships was known as the Donna. A colossal aircraft tire inner tube was inflated and picked up by the tower's cargo train that would traverse over the ocean. The tube, which had people in it, then plummeted straight down into the pitching and rolling ship below. Damage after Hurricane Donna forced the aircraft and its construction contractor to plan to begin to renovate the tower. The date for renovation was set to begin February 1st, 1961, and the crew that remained with the tower was a volunteer repair crew consisting of 14 Air Force and 14 civilian personnel. The ecological and economic impacts of the Texas Tower platforms involve consequences during the tower's installation, operation, dismantling, and the continued environmental services the sites still provide. After Texas Tower 4 suddenly plunged into the Atlantic Ocean, the program's evaluation led to the entire program ceasing. There was never a plan to replace TT4, and the American air defense only increased the number of air patrols it already had to fly to fill in the gaps of the Texas Tower radar system. There were near immediate ecological impacts of the towers being installed at sea. An underwater inspection occurred on February 8, 1960, and revealed that each leg was heavily coated with marine growth and mussel beds to a depth of -90 degrees. The seafloor had about 6 feet of sand built up around each leg footing, and there was a considerable amount of debris on the bottom, namely 50-gallon drums, construction steel, blocks, and hoses. Here are the direct construction costs. Notice the construction cost of Texas Tower 4 was the same price as Texas Tower 3, and almost $2 million cheaper than Texas Tower 2. The annual operating costs show that Texas Tower 4 cost more money every year, and even though it was the shortest-lived tower, the all-year total was the highest. After the collapse of TT4, new policies were written, and if exceeding weather conditions were forecasted, the tower was to be evacuated down to a 7-member standby crew. The purpose of this detachment was to guard against Soviet sailors attempting to board the platform and claim possession on the grounds of salvage rights. The only perceived way for the crew to remain alive long enough for rescue was through a survival capsule. The Texas Tower escape capsule would be a cramped and marginal device at best. The capsule was mentioned in the original Sea Lab publication. The introduction of Russian intercontinental ballistic missiles made the already ineffective radar system virtually obsolete. The speed of the missiles reduced the radar warning from 30 minutes to less than 1 minute. The safety issues were also considered. The advanced early warning aircraft that flew out of Otis Air Force Base already flew constant missions to scan for the Texas Tower radar web gaps. These planes only needed to increase their flight time. The EC-121 aircraft flew countless radar surveillance missions in the 1950s and 60s. They were known as the Super Constellation, and the airmen aboard were known as the Warning Stars. On January 15, 1963, TT2 was decommissioned, and the legs were dynamited, and they planned to float the platform to shore. Just like Texas Tower 4, Texas Tower 2 plunged into the ocean and sank to the bottom. Salvage was not possible, and the structure still sits on the bottom of the ocean today. TT3 was decommissioned on March 25, 1963. Since the other two platforms had sunk into the ocean, the bottom deck of TT3 was filled with urethane foam and ensured it was watertight before they dynamited the legs. This was the only radar platform that was salvaged, and the other two remain as fish havens at the bottom of the ocean. The case study reported that the designers lacked the environmental prediction techniques, which led to insufficient design criteria, the use of pin connections over fully welded joints, and an underestimation of some of the extreme environmental loads. Current predictions of such structures automatically generate masses that include the hydrodynamic added weight of the water and flooded members. Design engineers omitted the 3,200 tons of fluids held by the tower. Therefore, their calculations were based on a structure weighing 7,500 tons, instead of 10,800 tons. The case study also reported that many structural members were loaded beyond yield. This explains the extensive damage suffered during Hurricane Donna. It is incredible that the tower didn't fall down during that storm. It is likely that the design engineers overlooked the possibility of the legs buckling. The legs of Texas Tower 4 were different than the other two towers. In addition to the underwater braces, the lower part of the legs of Texas Tower 4 were used as ballast tanks during installation and fuel tanks after installation. This area was not reinforced with concrete. This section is the weak part of the leg, which broke near the footing during the fatal storm. The legs of Texas Tower 4 had an outer diameter of 12.5 feet and an 8-foot diameter tube extended from the top of the legs to 50 feet below the water surface. In between these tubes, stiffening concrete was poured to provide greater rigidity. Local buckling in unstiffened legs can be attributed to the legs having a huge diameter to thickness ratio, and rapid load shedding will occur after the onset of local buckling. This will bring the platform leg elements to a failure. A tripod has little redundancy in leg failure. After damage acquired in Hurricane Donna, above-water X-bracing was installed to stabilize the tower. This bracing went against the original design to keep bracing out of the wave action zone. On January 15, 1961, at 10:18 a.m., a wave warning was issued for Texas Tower 4, but neither the tower or the Otis Support Squadron ever acknowledged this. At about 1 p.m., Captain Phelan, who was the commander of the tower, called his wife who lived in Falmouth, and they had a long conversation. He told her that the tower was gyrating, a word Miss Phelan said she never heard him use to describe the tower before. Captain Phelan said it was rough on board, and she believed he was especially concerned about the wind and waves. She said they talked about what would happen if the tower collapsed, and he told her that it would not float. She asked if there were any watertight compartments, and he replied, "Absolutely not." The AKL-17, the Texas Tower support vessel, was in the sea near the tower in hopes of supporting an evacuation. Captain Phelan thought it was asinine for them to be around because it was impossible to use the Donna. If the tower fell, he told her, no one would be saved, and the AKL or any other craft would be useless. She asked if the tower would float for a short time to allow them to use the boat, and he said that when it went in, it would go in really fast. At about 4 p.m., Captain Phelan reported a loud noise, and he thought another brace had broken. At about 5:45, Captain Phelan received a call from Otis Air Force Base telling him that the USS Wasp, a Navy aircraft carrier with rescue helicopters, was being diverted and it would arrive sooner than choppers would from shore. The tower reported that all hands were on emergency call on deck, tossing everything they could overboard. At about 6 p.m., Captain Phelan called his wife again to tell her that they were finally sending the USS Wasp and evacuating them. He said safes containing classified materials were being thrown into the ocean, and everyone was working to keep the landing area clean. He told her that the waves were 35 feet and the wind was over 85 knots. The tower was breaking apart. At about 7:15, a tower official reported that all hands were still on deck to receive choppers, and then he said, "My next call to you will either be on the Wasp or I will be in the sea. So long." At about 7:20, Captain Manguel, the captain of the AKL-17, saw the radar signal disappear from the screen on his boat. He switched to another radar screen, but was still unable to locate the structure. He used the radio he had been in contact with Captain Phelan, but received no response. At 7:33, he transmitted a XXX message to the Coast Guard that Texas Tower 4 had disappeared from radar contact and he presumed it was lost. Extensive search and rescue efforts recovered no survivors, but they did find one airman's body still in the radio room. The exact cause of the collapse of the tower is unknown, but the most probable cause of the collapse is the failure of the leg structure because of ineffective bracing between the A and B legs, which caused buckling of the B leg and shearing of the A and C leg. Captain Gordon Phelan was the officer in charge, and he made special effort to communicate to the crew members aboard the day-to-day structural condition of the tower. His superiors cited his leadership for maintaining the high morale of fellow officers and subordinates aboard the doomed platform. He was recommended for the Legion of Merit Award when he prevented mass hysteria aboard the fully staffed tower during Hurricane Donna. As he did during Hurricane Donna, Captain Phelan likely maintained control of the military and civilian men on board. Mass hysteria aboard the trembling tower was the only other option. The airmen and civilians fought for each other, and they fought for their lives. They fought to keep the helicopter landing pad clear, but the helicopters had not taken off from the Wasp. Captain Phelan went down in the middle of the Atlantic with all men on board. There was no helm to command, no wheel or till to steer, and there was nothing they did that night on January 15, 1961, that did anything to help them. They were in a structure that was built more like a building than any ship, and it certainly wasn't watertight. The wreck sites of TT2 and TT4 could be designated as marine protected environments based on the legacy of the sacrifices and the ecological benefits the underwater wrecks still provide. This is not an event secluded to the past. The July 2020 sinking of a 26-ton amphibious assault vehicle in 385 feet of water caused 8 Marines and a sailor to drown to death. The incident resulted from inadequate training, a vehicle in horrible condition, and lapsed safety. The Captain Phelan MPA will protect the natural resources provided by the underwater wrecks and preserve the history of our coastal defense. Thank you for watching my presentation. I hope you learned something, and please remember the sacrifices made. All photos are from Radome's Texas Tower Online Museum, and I suggest you view it.